The end of materialist science. Master and mastered. Although physicists are quite sure that quantum mechanics provides a complete explanation for the nature of the chemical bond, and so for all of chemistry, they are sure of a great many things that may not be so, and they have provided the requisite calculations only for the hydrogen and helium atoms. Quantum mechanics was, of course, created before the advent of the computer. It is a superbly linear theory, its equations admit of exact solution. But beyond the simplest of systems, a computational wilderness arises: mangrove trees, steaming swamps, some horrid thing shambling through the undergrowth, eager to engage the physicists, and the rest of us, in conversation. Hey, fellas, wait. The fundamental laws of physics are in control of the fundamental physical objects, giving instructions to the quarks and bossing around the gluons. The mathematician yet rules the elementary quantum world, but beyond their natural domain, the influence of the fundamental laws is transmitted only by interpretation. As complex systems of particles are studied, equations must be introduced for each particle, the equations, together with their fearful interactions, settled and then solved. There is no hope of doing this analytically, the difficulties tend to accumulate exponentially. Very powerful computers are required. Between the music of Mozart and the fundamental laws of physics, the triple concepts of algorithm, information, and symbol hold sway. The content of the fundamental laws of physics is relative. It must be relative to the computational systems needed to interpret them. There is a world of difference between the character of the fundamental laws, on the one hand, and the nature of the computations required to breathe life into them, on the other. The statement that a group of rabbits is roughly doubling its size suggests to a mathematician an underlying law of growth. The rabbits are reproducing themselves exponentially. The law provides a general description of how the rabbits are increasing, one good for all time. It is an analytical statement. It strikes to the heart of things by accounting for what the rabbits are doing by means of a precise mathematical function. Observing those same rabbits over a certain period of time, the computer tracks their growth in a finite number of steps. There are 2 rabbits to begin with, and then 4 and then 8, and so upward to 64, when this imaginary exercise ceases on my say-so. The finite collection of numbers is a simulation, one in which the underlying reality is suggested, but never fully described. Law and simulation have very different natures, very different properties. The law is infinite, describing the increase in rabbits to the very end of time, and the law, moreover, is continuous, and so a part of the great tradition of mathematical description that is tied ultimately to the calculus. The simulation is neither infinite nor continuous, but finite and discrete. It provides no deep mathematical function to explain anything in nature. It specifies only a series of numbers, the conversion of those numbers into a pattern a matter for the mathematician to decide. If the law describes the hidden heart of things, the simulation provides only a series of stylized snapshots, akin really to the succession of old-fashioned stills that New York tabloids used to feature. The woman, her skirt askew, falling from the 6th-floor window, then passing the 3rd floor, a look of alarm on her disorganized features, finally landing on the hood of an automobile, woman and hood both crumpled. The lack of continuity in either scheme makes any interpolation between shots or simulation a calculated conjecture. The snapshots, it is worthwhile to recall, provide no evidence that the woman was falling down, but we see the pictures and we neglect the contribution we make to their interpretation. Computational schemes figure in any description of the inferential staircase. The triple concepts of algorithm, information, and symbol have made yet another appearance. They are like the sun, which comes up anew each day. And they serve to sound a relentlessly human voice. The expectation among physicists, of course, is that these concepts play merely an ancillary role, the inferential staircase under construction essentially by means of the fundamental laws of physics. But the question of who is to be the master and who the mastered in this business is anything but clear. To the extent that the fundamental laws of physics function as premises to a grand metaphysical argument, one in which the universe is to appear as its Empyrean conclusion, the triple concepts algorithm, information, symbol function as additional premises. Without those premises, the laws of physics would sit simply in the shedding sun, mute, inglorious, and unrevealing. A third revision of Steven Weinberg's memorable affirmation is now in prospect. The best that can be expected, the most extreme hope for science, is an explanation of all natural phenomena on the basis of the fundamental laws of physics, and chance, and a congeries of computational schemes, algorithms, specialized programming languages, techniques for numerical integration, huge canned programs, such as Mathematica or Maple, computer graphics, interpolation methods, computer-theoretic shortcuts, and the best efforts by mathematicians and physicists to convert the data of simulation into coherent patterns, artfully revealing symmetries and continuous narratives. A certain sense of radiant simplicity may now be observed dimming itself. The greater the contribution of the triple concepts, the less compelling the vision of an inferential staircase. Matters stand on a destructive dilemma. Without the triple concepts, the fundamental laws of physics are incomplete, but with the triple concepts in place, they are no longer simple. The inferential staircase was to have led from the laws of physics to that sense of intelligence by which complexity is explained. If intelligence is required to construct the very stairs themselves, why bother climbing them? The profoundly simple statements that were to have redeemed the world must do their redeeming by means of the very concepts that they were intended to redeem.